this chapter, we're going to study angles and reasoning. In this lesson, we're going to look specifically at angle relationships.
All right, hi everybody. So in this chapter we're looking at angles and reasoning. And right now specifically in this lesson we're going to look at angle relationships, okay? So a lot of this stuff you may have seen before, so we're just going to kind of run over this and review it with you. So first of all, we want to talk about types of angles, okay? And so we're going to draw an arc to represent the angle x degrees in each case here. So an acute angle is any angle that's between 0 and 90 degrees, right? So this angle right here, this is going to be our angle x, less than 90 degrees. Now right here, the right angle, and we would usually use a little box like that to denote a right angle, if we know for sure that it is a right angle. Okay, and that's going to be 90 degrees. One of the things that I would caution you about here is don't assume just because an angle looks like it's 90 degrees that it is. Okay, oftentimes that needs to be labeled so that you can make that assumption, or you're going to need to verify or prove that that's actually the case. If an angle is greater than 90 degrees but less than 180, we call that an obtuse angle. If an angle is 180 degrees, now that means this is why I really have to draw that arc there. If we open something up here, an angle up here, and it rotates halfway around, so it's let's say we're facing this way, we rotate around so we're facing this way, now that's 180 degrees. We call that a straight angle. A reflex angle is any angle that's now greater than 180 but less than 360. And then over here, a complete rotation, and this is maybe drawn a little wrong here because we've been grabbing all the angles from the middle here, but what this would be is basically an angle that rotates around like that. That's a complete rotation, 360 degrees. Okay? So now what we're going to do is we're going to go through kind of section by section, focusing on like specific relationships here. So the first thing we want to look at here are what we call angles of a straight line. And when you've got two angles that add up to 180 degrees to form that straight line, so for example, let's say you've got, here's your two angles here. So this angle, let's call this alpha, and this angle right here is maybe beta. We know that the sum of those two angles must be 180 degrees because the result is a straight angle. And so that's what we're going to use to answer some of these next questions. And when that happens, we call those supplementary angles. Okay? When their sum is 180 degrees, that is what we call supplementary angles. Okay, so now all we have to do in this next little section here is just going to calculate the unknown angle here. Well, here we go. We see that this is going to be a straight angle, the sum of those two. So these two angles are supplementary. So I know that 155 degrees plus A degrees is going to equal 180 degrees. So A degrees is simply going to be 180 minus 155. And so what's 180 minus 155? 25 degrees. Okay? So I easily can figure out what A is. Here, I see that these three angles are all adding up to 180. So 51 degrees plus 68 degrees plus B is equal to 180 degrees. Now I'm running into that, but that's okay. So 51 plus 68 is going to be 119 degrees plus B degrees is equal to 180, which means B is going to be 180 degrees minus 119 degrees. So what does that equal? Okay, let's just think about that for a second here, and I think you'll see that that's going to be 61 degrees. Okay, I can verify that by simply adding. 1 and 9 is going to give us that 10 is going to carry the 1 and 6, the 2 and 6 will be 8, yeah, so 180 degrees. So there we go. So that angle there's got to be 61 degrees. Here, ooh, now there's a lot here that we need to figure out. But I can tell right now that 80 degrees plus C is going to equal 180 degrees. Okay, these two together are going to give me 180 degrees. That's a straight line. And that's a quick calculation. I'll just subtract 80 from both sides and I'll get that C is equal to 100 degrees. Now, once I know that, I also know that these two have to add up to 180, which means 100 degrees, that's angle C, plus E must equal 180. Well, that means that E must be 80 degrees. And once I know that those two must equal 180, okay, to give us this straight line. So I know that angle E, which is 80 degrees, plus D has got to equal 180 degrees. So D must be 100 degrees. Okay, so just by applying that rule repeatedly, I can go all the way around that full circle there. And this actually leads to this next idea that we're going to look at. Okay, so vertically opposite angles are formed when we have two straight lines that cross here in like that X shape, okay, like that. So right here is our vertex. Angles that are on opposite sides of that intersection here are what we call vertically opposite, and vertically opposite angles are equal. And we just saw that with the example that we did. Just knowing that this was 80 degrees and applying the rule about straight angles on a straight line here, I know that these two have to add up to 180, but so do these two, and that means that these two angles must be the same. And then by kind of furthering that logic, I know that these two angles must be the same, and my calculations verified that as well. So now what we want to do is we just want to apply this knowledge and use it to calculate the values of given angles. Okay, so this question is telling us to calculate the unknown angles here. Well, because I've got this rule now about vertically opposite angles, this actually becomes really, really easy. I've got two lines that are crossed here, so I know that X must equal 105 degrees. And I know that Y must equal 75 degrees. Has to be that way. I don't even really have to do a calculation. I just know that those are going to be equal. When we take a look at this one, same sort of thing. Now I've got a little bit of a lack of information here, but I do know, because these are two lines that are crossing, that 130 and angle B are going to be vertically opposite. So I know that B is going to equal 130 degrees. And now I can apply the knowledge that I had from the previous rule that we looked at. I know that A, for example, at 130 must be supplementary because they're forming a straight line. So I know 130 degrees plus A degrees must equal 180 degrees, which means A must be the difference between the two. So I'll subtract 130 to get 50 degrees. And if A is 50 degrees, because A and C are vertically opposite, I know that C, therefore C must also be 50 degrees. So just in case you hadn't seen that before, the three dots in that triangle mean therefore. Okay, so there you go. Okay, now let's look at another rule. Angles around a point. So now we've already seen, like it says here, the supplementary angles form one side of a straight line, and then they have a sum of 180 degrees, okay? 100 supplementary angles. Now, if you go all the way around the full circle though, then that's all those angles together that form that full rotation. They have to add up to 360 degrees. Okay, I think if you just think about that, that makes total sense here. Like I've got, so here's my crosshairs, for example. If I got an angle there, all of these little angles together, if I add those all up, that's got to be 360 degrees because they all form a complete rotation. Anyway, so now we can just use that to find some missing angles in a problem. Okay, so this question says calculate the unknown angles. Okay, so in this question right here, going around the full circle here, I simply know that 52 degrees plus 57 degrees plus 71 degrees plus, I got to wrap around, 80 degrees plus A degrees must equal 360 degrees. So A, okay, is going to equal 360 degrees minus, and I'm going to take away all those angles from it, 52 minus 57 degrees minus 71 degrees minus 80 degrees. I'm just going to remove all of those pieces to the other side. Now instead of doing that just in my head here, I'm just going to let the calculator handle that problem just to get through it a little bit quicker. So 360 minus 52 minus 57 minus 71 minus 80, and we get 100 degrees. So A is equal to 100 degrees. Now, probably could have figured that out, okay? If I had figured out that these, if I'd looked closely and seen that those three angles added up to 180, and the truth is when I look at them a little bit more closely, they do. I see that right away. So I would have known that these two have to add up to 180, which would have made that a little easier. But that's okay, I didn't need to, and I wanted to apply this rule. Let's take a look at this one. So here, we've got 60, 55, and 120, okay? Now, I notice I've got two unknowns here. Oh, now that's a little tough. Okay, that's a little tough because with two unknowns, I mean, maybe I'm not 100% sure how the lines are drawn there, so I'm not entirely sure how big they are. However, there's a bit of an implication here, like this looks like a straight line, that looks like a straight line, which communicates to me that B here, because these two angles are vertically opposite, B must be 60 degrees, and I believe that's what they're trying to get at. Another thing that I might have looked at here is that these angles right here have to add up to 180. Okay, because of the fact that this is a straight line right here. I mean, I used that really to figure out that this was 60. Now, except what I want to kind of emphasize here is the rule that we're trying to learn right now. I know that angle C must be 360 degrees minus 60 minus 55 degrees minus 60 degrees for the angle B here minus 120 degrees. Okay, and so now I'll go to my calculator and I'll plug that in. So 360 minus 60 minus 55 minus 60 minus 120, and we get 65. So angle C has got to equal 65 degrees. Now, there are other ways of getting angle C. Please don't get me wrong here. I'm just trying to point out that, again, and use this rule, that the sum of the angles around that point right there are going to add up to 360 degrees. Okay, now we want to take or talk a little bit about triangles. I just want to remind you of a couple properties of triangles that you're probably already quite familiar with, but just want to kind of bring them back up to the forefront of your mind again here. With triangles, the sum of all the angles in a triangle, sum of all three angles in a triangle is 180 degrees, okay? As long as it's a flat triangle. Now, another rule here that we want you to know here is that if you've got an isosceles triangle, in an isosceles triangle, two sides are the same. Okay, that's what it means. We don't know about the third side here, but the two sides are the same. And if those two sides are the same, then we know that these two angles here must also be the same, the base angles. Basically, what we're trying to say here with that rule is that the size of an angle, okay, when this angle opens up to this side, in that same triangle, if this angle opens up and the two sides are the same length, those angles must be the same. Basically, that's kind of like saying this rule right here. Let's say I've got a triangle that does something like this. Well, which angle in the triangle is the largest? Well, it's this angle right here. Which side in this triangle is the largest? Well, it's this side right here, okay? And there's a relationship there. The smallest angle in the triangle, in this diagram here, I kind of didn't do myself any favors here, probably would draw it like that. The smallest angle in the triangle would be this one, and it opens up to the smallest side, okay? So the largest angle opens up to the largest side, the smallest angle opens up to the smallest side. And that's basically what we're seeing in the isosceles triangle. When those two sides are the same, that means these two angles are opening up to the same sized side. They will be the same size. I mean, even in my head that sounded weird, but hopefully you get the idea. Now, there's one other rule we want to take a look at before we do some questions here. Sorry. And that's this rule right here. In the diagram below, X is the exterior angle. So if you take a triangle and you extend a side, the angle that's formed between that side of the triangle and the extension is going to be X. It's called the external angle, or an exterior angle. Now, this angle, angle C and angle X here, C plus X, must equal 180 degrees because this is a straight line. So together these are supplementary angles. But I also know that C plus A plus B is also equal to 180 degrees. Okay, because the three angles inside a triangle here. Which means if C plus X is 180 and C plus A plus B is 180, I know that X must be the same as the sum of these two angles here. Okay? Does that make, I hope that makes sense here. I mean, we could do this algebraically if we wanted as well. What we might have done here, just to take it one step further, was to say that X is going to equal 180 degrees minus C degrees. A plus B is going to be 180 degrees minus C degrees. And notice they are both equal to the same thing. So those two must be equal to each other. Okay? So that's the rule right here. The exterior angle of a triangle, okay, after extending a side, that angle right there, is always going to equal the sum of the two interior opposite angles on the other side of the triangle. Okay, so now we're just going to run through some problems. We're going to calculate the unknown angles here. Okay, so for the first question, here's my unknown, and I've got 83 and 65. Well, I know that X plus 83 plus 65 must equal 180 because the angles in a triangle have to add up to 180. So I'll now move these two over to the other side, which means 180 minus 83 degrees minus 65 degrees is going to equal X. And now I'll just let the calculator do that because I don't want to do that and make a mistake in my head there. And I'm going to get that X is 32 degrees. Okay? Let's take a look at this one. Now here, I want to figure out what, we got a bunch of unknowns here. Well, here's 90 degrees. And if this is 90 degrees, we know that this is also 90 degrees. Okay? These two angles here are forming a straight line, so together they must add up to 180. So I can tell that that's going to be 90. I know that these three angles right here, okay, should add up, to 180. So I know that D plus 36 degrees plus 90 degrees is going to equal 180. So D is going to equal 180 minus 90 degrees minus 36 degrees. Okay? And I believe that is going to be, 54 degrees. So I know right now that D is equal to 54. Okay, so now I can use that to figure out what B is, because I know that B should be the sum of the, because it's an exterior angle to that triangle, it should be the sum of the opposite interior angle. So it should be the sum of angle D and 90 degrees. Well, D, we just figured out was 54. Oh, it doesn't really look like a 54. Hold on, let me redo that. 54 degrees plus 90 degrees. So it's going to be 144 degrees. Now, I can do a similar sort of thing on the other side of this diagram, just in the opposite direction here. I know that A plus 29 must equal 180 because these are they're two angles on a straight line here, so they're supplementary angles. So I know that A degrees plus 29 degrees is equal to 180, which means A is going to be 180 degrees minus 29 degrees, and that's going to be 151 degrees. So I know that A is 151. Easy. I also know that the sum of these two interior opposite sides should be equal to A. So I know that C plus 90 degrees should equal 151 degrees. Okay? And so now, if I bring that 90 over, C is going to equal 151 degrees minus 90 degrees, or 61 degrees. Okay? Isn't it nice how all those rules work together, and you can actually use them in two different orders there to get the things that you're looking for. Let's do another one here. Let's see a little bit. Okay, now we got a lot going on with this one. Well, let's start with a couple that are going to be fairly easy for us to figure out here. We know that Q and 111 must add up to 180 degrees. So now I'm just going to start to write this a little bit quicker here. So I know that Q must equal 180 minus 111 degrees. Okay? So I'll just do this with my calculator over here. And I know that this is going to be 69 degrees right there. There's Q. I know that P has to equal 180 degrees minus 128 degrees. Okay, because again, we're looking at two angles that are supplementary, that are forming a straight angle. And that means that P is going to be 52 degrees. Awesome. Now, I've got two angles inside a triangle. I can use that to figure out what R is. I know that this R, at least I think it's the letter R is going to be 180 degrees minus the two angles I just found. So minus 69 degrees minus 52 degrees. Okay, so 180 minus 52 minus 69 is going to equal 59 degrees. So there we go. So slowly but surely just making our way around here. I've got Q, I've got P, I've got R. Now, because I know, I'll do it this way. Because S is an exterior angle of this triangle, I know that it's going to be equal to the sum of P and Q. Okay, I know that S must be the sum of P degrees plus Q degrees. So that's going to be 52 degrees, whoops, can't see that, plus 69 degrees. So 52 plus 69 is going to be 121 degrees. That actually makes sense. The diagram's got to be fairly close to, well, not 100%. I mean, it's not great, but you can see that that's a little bit greater than 90. This is more than just a little bit bigger than 90, but yeah, it's bigger than 90 there. And then finally, oh, I wish I could just use vertically opposite angles to get T out of this, but that's not the way that works here. What I got to do here is I know that T is going to equal 180 degrees minus 71 degrees. Those are going to add up to 180. They're supplementary. So 180 minus that 71, T is going to equal 109 degrees. Okay, and so there you go. All the pieces that we want to find here, and that's not the only way you could have done it. You could have done that in a bunch of different ways. This is just one way that you could approach that problem. Now let's look at this one. Okay, so I've got 34 degrees, and then basically everything else is unknown. But I am given that this is an isosceles triangle. And if it's isosceles, then the two angles that open up to the two sides, the two equal sides, those must be equal. So therefore, I know that D also has to equal 34 degrees. There can be no debate about that. And then T, oh, that's right, that's F. F is an exterior angle. So F is going to equal the sum of the two inside opposite angles. So it's going to be 34 degrees plus 34 degrees. So F is going to be 68 degrees. And then E, well, E and F are supplementary. Together they form a straight line. So it's going to be 180 degrees minus 68 degrees. Okay, so 180 minus 68 will be 112 degrees. Not the only way I could have done that. Once I knew that those two are 68, I could have used the rule that the sum of the angles in a triangle is 180. There are a few different ways I can approach all of these problems here. This is just a few. I hope you like working with these sorts of problems here. I like them. I think they're kind of fun. Okay, so just as we wrap up here, just in summary, we've been looking at some angle relationships here. So just to recall here what we've done, angles on one side of a straight line add up to 180 degrees. So here's a straight line. I do that. These two angles here, alpha and beta, alpha plus beta will equal 180 degrees. Opposite angles at a vertex when they're created by two straight lines, okay, the vertically opposite angles are going to be the same. Angles around a point add up to 360 degrees. Okay, all of these angles together add up to 360 degrees. Okay, the sum of the three angles in every triangle Okay, A, B, C, A plus B plus C is going to equal 180 degrees. Okay, that's going to be true of every triangle that lies on a flat plane. And the exterior angle of a triangle is always going to be equal to the sum of the two opposite interior angles. So I've got my triangle here. I know that this angle right here, A, if I call this B and C, I know that A is going to equal B plus C. Okay, and those are our rules.